what is the formula for current intensity? Now, if we look at current intensity, I is equal to Q over delta T. The reason we say that, because the concept of current intensity is the amount of charge or the amount of electrons that pass a specific point in a circuit every second. Okay, so they're giving you an amount, okay, of electrons basically. Now, potential difference, on the other hand, is going to be measuring something else. Where current intensity measures the actual charge passing through one point in the circuit every second, okay? Every second it's measuring charge. Potential difference, on the other hand, is not measuring charge. It is measuring the amount of energy that passes between any 2 points in a circuit. And the example I want to use there is photoradar. Photoradar kind of works along the same concept in that, have you ever driven through a photoradar? Yeah. Okay, so I'm just going to draw this out. So in order to understand what potential difference is, I'm going to just show you what I mean by photoradar. Photoradar works by having two actual cameras spaced out on a road. Okay, so the road is here, okay, and they're on the side of the road. So traffic is moving in this direction, all right? So what ends up happening here is that this car, so if I'm I'm just going to make a box with wheels, okay, so this car, a photo is taken of this car in this direction as soon as the car passes a certain marker. And then as this car moves along the street, the camera here, so this is camera 1, this is camera 2. Camera 2 will then take a picture of the car here. And it's the amount of time that elapses between these two photos that they can determine what your speed is. Because velocity and speed, okay, more or less follow the same principle, the amount of distance you've covered over the amount of time it took you to get there. All right, and so that's why you would get a ticket in the mail if they actually have proof that you've, been going too fast. So the idea of potential difference, it kind of does the same thing. So when we look at potential difference, what we're talking about is the amount of energy going through that circuit, and they're starting measurement at point A and they end it at point B. And we actually use a tool to measure that amount of energy. It's called a voltmeter. And I'm going to, after I draw out the formula here, I'm going to draw out two little circuit diagrams to show you what we mean by this. Okay? So when we talk about the formula for potential difference, we're measuring the amount of energy. Okay? And the amount of electrical energy, in this case, is measured in volts. All right? So volts, or potential difference, is going to be equal to the amount of energy, okay, in relation to the actual charge. All right? Okay, look at these two formulas. There's one similarity between the two of them. What is it? They both have charge in their formula. So right here, you're going to start to see that different formulas have some of these same units coming back. Okay, some of these same different kind of, what's the word I'm looking for? Okay, they have these same variables, and so we're going to see that when we're trying to solve some of these mathematical problems, we might be given something, let's say, we might be given an object's voltage and its energy where we have to find Q. And then we have to use that Q in the current intensity formula to find I. Okay, these are things that you could be given, and we will work through examples of that. All right, but just so I'm really glad that you picked up on the fact that Q appears in both of these formulas. So right now I'm going to draw out the circuit diagrams for something measuring current intensity versus something measuring voltage, okay, or potential difference. When we're measuring current intensity, okay, if we remember, current intensity is the number of charges that flow past a given point in the electrical circuit. Okay, so what we're looking at here, that energy is actually leaving the power supply, which is right here, and it's traveling through this, it's going into this machine, into this little resistor. The resistor's doing something, and then it comes out the other end of the resistor, and it keeps going back to the power supply. That is the loop that is created in a circuit, okay? So when we're actually talking about measuring the amount of current at any one point, we have to include that machine into the loop of the circuit. So what we do, and it doesn't really matter where, what we do is we include the box, okay? That is our ammeter. And we're going to learn how to set that up. The ammeter does not take any energy to operate. It doesn't take away any of the actual energy that would likely go to a light bulb or something. All right? But it gives us a reading, and from that we can determine what an object's current, what the current intensity is going through that circuit. So these guys, they're in every circuit. The circuits we make, they will be there. They do not take any energy. So I'm going to add that guy over here, okay? Because even though we're not measuring the same thing, it's part of the circuit. Now, at every point, every time energy or charge is passing the box with the A is taking a reading every second. Okay? And it's giving you that average reading of how much current is in that circuit. Now, to measure potential difference, on the other hand, if we look at the definition there, potential difference is the amount of energy transferred between two separate points in one circuit. And normally what we like to do, if I look at this circuit here, okay, and if I say that point A is right here at the start of this wire, and point B is going to be at the end of the wire here. Is anything taking place there other than just wire connecting? No. So nothing's going to be, there shouldn't be any energy change here. If I put my voltmeter here and here, okay, those are my 2 points, well, I'm going to have the same reading of energy here as I would here, because there's nothing in there that might be using some of that energy, right? So I don't want to do that. So what I end up doing, okay, is when we actually use a voltmeter is never part of the circuit loop. It's always on the outside trying to get in. And what I mean by that is we will be practicing putting voltmeters around each of the objects that we put into our circuits. Light bulbs and little ceramic resistors, okay? Because they're going to actually take energy and use that energy to do something. What does a light bulb do with the energy that goes through with it? It lights up, right? It makes light. That takes energy, okay? So if I want to measure the amount of energy that that light bulb is taking, I would, okay, place my one bit of my voltmeter at the beginning, And I would then place the other bit of my voltmeter here. And what ends up happening, as the circuit, as the energy goes through that circuit, okay, it's going to go into the circuit here. And it's going to go through this. Something's going to happen. And then it's going to come out. And it's going to keep on going back to the power supply. The voltmeter is going to take the reading here. And then it's going to take the reading after, just like photoradar. And it's going to calculate the amount of energy that that object in the circuit is using. It's going to give us a number. We're then going to be able to plug that number into our equations to determine certain things. Okay, so the little kind of mnemonic or the little kind of memory sort of aid that we use is the concept that if you're in the circle of friends, if you're in the circle that is, or the loop that is the circuit, okay, the ammeter is part of the circle of friends. It's part of the loop. Ammeter is always within the circuit, whereas the voltmeter is always on the outside looking in. It's branching at the beginning of an object and branching at the end of an object to get the reading of that object. Now for this circuit, that's not going to be too crazy because all the energy coming out of that power supply is going to go right to that light bulb. Where it gets interesting though is when you have more than one light bulb and they're set up in a variety of ways, which we will get to. Okay? That's where taking all these readings is going to become important. All right? So we'll talk about that later. So do we see the difference here between these two formulas and what they actually measure? Perfect.